Welcome to the welding portion of the print reading class here at Kilgore College. My name is Evan Rodolescu. I'm one of the welding instructors up here. Today I'm going to be going over Unit 1 real quick, and what we're going to be covering is basic lines and views of reading a print. All right. So we've kind of already gone over what lines, vertexes, and planes are as far as what a print represents whenever it's drawn. So today we're going to go over some of the basic lines and basic views that make up these prints. So one of the objectives of this chapter is that we're going to identify and describe the uses of common line types, and we're going to identify two different methods in which an object is represented on a print. We're going to identify the proper orientation of the views used in an orthographic projection. All right? Orthographic projection just being three different views of an object. All right, we usually have our front, our top, and a right side view, or it could even be a left side view, but usually on an orthographic you're going to get three views. So usually with the orthographic drawing you will have three views. You'll have the front view. I really think it's the best way to show you with this. So each object you can think of, this is a square three-dimensional object. We have our front, which is our F basically. So whenever you get a drawing, you'll see this front side view. You have our top, so if you were to actually take the object, here's your front, and rotate it and physically view that object from the top, that's the view that you're seeing whenever you see a top view on an orthographic projection, okay? I'm gonna rotate it back to the front. So here we have our front, and then from there we can rotate it to our right side view, okay? So any part of the drawing you see on an orthographic from the right side, you imagine that you've taken it from the front, you've turned it to the right side. Any view you see from the top, you've taken it from the front and rotated it to the top, okay? These are the three main views that you're going to see whenever you see an orthographic projection or an orthographic drawing or print. Now, there are other views as well. We have our left side. Go back to the front for orientation. We have the bottom, and go back to the front right here. Then we can go from the front to the top all the way to the back of the object. So anytime you're viewing one of these views, you're actually turning the object and viewing it from that side. So if you're viewing it from the left side, you're actually viewing the drawing like that, okay? Now, on drawings, we have different types of line that represent different, that will tell you different things, okay? We've got lines are used on a drawing to determine the shape of an object and dimensioning as well, all right? Some of the basic line types we're going to go over real quick. We have the object line, which is a thick, solid line to show the visible shape of a part outline of an object, all right? So an object line is what you can visibly see from that view. Then we have the hidden line, which is a broken line of medium thickness, and that hidden line will show you edges and outlines that are not visible to the eye itself. So if you're looking at the front view of something, but there's another part behind it, it'll be represented by a hidden line instead. A center line is a fine broken line made up of a series of short and long dashes alternatively spaced, okay, to show the center of circles, arcs, and symmetrical objects, and to aid in dimensioning these parts. And then we have extension lines and dimension lines. Extension lines are lines that extend from the object with a slight break between dimension lines and a fine line with arrowheads, unbroken except where the dimension is placed. The dimension lines are not an actual part of the object. They're just there to let you know the size of the object and give you a dimension that'll determine its size, whether it be in inches, centimeters, millimeters, any dimensions like that. Extension lines, they show dimensioning points, and the lines touch the extension lines and show distance given by the dimensions. All right. And then we have leader lines. They're a fine straight line with either an arrowhead or a round solid dot on one end. It is usually drawn at an angle what the leader line is going to do is it's going to point directly to the surface for the purpose of dimensioning or adding a note. A dot is used at the end of a straight line where it is reference is made to a surface area. So if I'm talking about this part right here and there is a leader line pointing to it, if it has an end of an arrow and it's pointing to this hole right here and it has information like 1/2 inch, it will say 1/2 inch drill hold. That's a little note on there letting me know that that specific point is a 1/2 inch hole. Now, I can have center lines going through these holes as well, either this way or this way, and that'll let me know where the center line is on these holes, okay? And I can also have another center line going up the middle of this object to actually split the object in half and let you know where the center of this part is, or it could even let you know the center of these holes are as well. And then off of those center lines, you can build dimension lines, and they'll actually tell you the distances between these holes and the distances from the end to the center of the hole as well. So that'd be the use of the dimension lines. Now, a basic orthographic print of this object right here. So we're going to call this our front. This will be our top. Go back to our front. And this would be our right side view. So a print for this would end up looking just like this. So you'd have, this is your front side view, and all of these solid thicker lines here, these are all object lines. From this view, these are all visible edges of the part, all right? Now these little dashed lines right here, these are our hidden lines. Because, as you can see from our top view, there are holes in this part. You can't see it from the front view. So to represent those holes that are bored through or drilled through, you can actually see the hidden lines. And this represents the edges of these holes there and there. And that's what those hidden lines are showing us. So to have that front view here, our object lines are what we visibly see, and then our hidden lines are what we don't see. And those hidden lines are representing the edges right there. Then from our top view, you see we have this object line going across here, and it's letting us know that this part has this extension off of it up here to the side. So instead of it just being a plain rectangle all the way around, we can see our holes that'll be put into it. And then you also see another line here. So with prints, we have our lines, vertexes, and planes. Each plane being one of these whole flat surfaces right here. And every time there's a different plane, there'll be an object line. So when viewed from the top, you can very easily turn this to the side a little bit because it's a 3D object, and you can see that there's a break right here. But if you were to just draw this flat, you need to add an extra object line right here to let you know that this is one plane and this is another plane, all right? Now, onto our, so top, this is our front side, and this would be our right side view. Now, the right side view, if you were just to see this as a visible plane, all you see is just this one rectangular plane right here. But you can also see I've got a hidden line representing the other plane that exists behind this from where this extends up. And then you've got hidden lines here for where the holes are that are drilled through this part. So whenever you see a print like this, you can know what the object is going to look like based off of these three views. You could go out there and you could either machine a part like this, or you could weld together a part like this and fabricate it, and you'd know what it need to look like in real life based off of these three views, because they are the ones essential to know where the holes are, where the points are for these planes, and the orientation of it itself. There are a couple other different types of lines. We have cutting planes. The cutting plane is the preferred line, is a heavy broken line made up of a series of one long and two short dashes, alternately spaced. Arrowheads are placed at right angles to the cutting plane line as shown. Alternate cutting plane lines are a solid heavy line or a series of long dashes. Now, the purpose of a cutting plane is to indicate where an imaginary cut is made through the object. The arrow points in the direction in which that section should be viewed. Letters next to the arrows identify the section in cases where more than one section is shown on the drawing. These lines are oriented vertically, horizontally, or at the actual angle at what the part is drawn. And we have section lines. These are a series of lines are solid and broken, and they're arranged in a specific pattern. Now, these lines are represented to the cutout surface of a material or a plane that's been cut through, and these section lines can represent different types of material, whether it be steel, cast iron, copper, bronze, zinc, lead. It's not something you run into too much these days because there isn't a standardized pattern for each part or each type of line whenever it comes to a type of material. Usually individual companies will have their own pattern for certain materials so that they'll usually have a key that they work off of that's company-wide. They're usually drawn at a 45-degree angle. However, this angle will vary when applied to adjacent parts. So if one part's rotated 20 degrees, it's not going to be perfectly 45 to the other section lines that are on the other part because the part's slightly rotated. And all these lines are used for is to indicate the imaginary cut surface referred to by the cutting plane line to represent various kinds of materials. Now, the other type of lines we have are a chain line. It's a heavy broken line made up of a series of long and short dashes, alternately spaced. Indicates the location and extent of a surface area. We have the short break line. It's a heavy irregular line drawn freehand to show a short break, to conserve space on a drawing, to show a partial section. Short break would be used in the sense of if you had a pipeline or if you've got an object like, let's say, a book frame that you're building and it's going to be 8 feet long. Well, if you don't have that much room on the paper to show it, you just draw on a little short break and you can shorten it up on the drawing itself and then use the dimensions to actually let you know how large the object is, because in some cases it may not be the size or to scale on that print, so you use those short breaks to represent that. Long break is a ruled light line with freehand zigzags, and this will show a long break to conserve space on a drawing. Long breaks are more used in something like a series of pipe construction. If you were just welding on fittings onto a print, you don't need 40 feet of pipe shown in a drawing. You only need the end flanges on each side of the pipe. So to save space, they'll put a long break in there to make it easier on them and make the print be able to fit the piece of paper. And you have a phantom line. It's a light broken line made up of a series of 1 long and 2 short dashes. This will show alternative positions of a part to show a relationship of existing part to a new part or to show a machined surface. So for a phantom line, if this part or this area was to be machined later, it could have a phantom line on it, or if there was another piece that was going to be added to it, later on, it would be drawn with a phantom line, or if it was even showing an alternative position, like if this had a hinge on it somewhere, it could show another position of the material on there as well. So drawings described an object in sufficient detail to permit fabrication. You aren't going to have a drawing with an excessive amount of info. It's going to have what you need to build it, all right? Orthographic projection, exact form of the object shown by various views. So the orthographic projection, again, we've got our front, our top, and our right side view. Views have a definite arrangement, all right? The top view is going to be above the front view, and the right side view is going to be in line with the front view to the side of it, in accordance with third angle orthographic projection. There is first angle orthographic projection, but that's used more in the metric system, and we'll go over that later. What we have is front, right side, and top view, and each view will be aligned with each other in the orientation of the part. So the sides of the front piece are in line with the top side of the top view. So you see how these lines align with each other. And then on the right side view, they align as well with the bottom of the print to the top part right in here. So the top of the part lines up with the bottom of the part. This print may not do that so exactly because this is a hand-drawn print that I made, but on more professional CAD style drawings or anything that's actually being made for in the field use, these will all align with each other exactly. You can even see these holes line up with each other in their place, and then these lines here line up with each other as well. So on top of the orthographic drawings, we have two other styles as well. We have a 3D sort of representation or a pictorial drawing, and there's two major pictorials that we'll use. One is the oblique angle drawing. It's a little wonky in the sense that you'll have the right side shown and then the front off to the side and top. And one corner will be at a 90-degree angle and the other will be at a 45. Now, the only disadvantage of this is that oblique drawings kind of warp the shape. They kind of take it, and let's say this was our front side view here. It'd be off to the side, and then it just basically break the object and make this at a 45 angle. Now, isometrics are a lot more preferred in my opinion because everything's held at a 30-degree angle instead of an oblique where everything's broken and it's kind of a warped shape. We've got in an isometric, everything's based off of a 30-degree angle. So you've got your front side view, you've got your top view, which you'll be able to view with this pictorial and the right side. Now the pictorial view you'll run into more often is an isometric view, mostly because it does not actually break the object or cause an optical illusion. Everything's set at a 30-degree angle. So you'll have your front side, your top side, and your right side view, and the object will be represented just like that. It's a lot easier to see in a three-dimensional space, in my opinion, than an oblique drawing, because the oblique actually warps the object and takes a plane and slide it off to the side. And of course, we have our orthographic projection, front, right, and top side view. As you can see on this slide right here, these are our three different types. We've got our two pictorials above, we've got oblique and isometric, and below it we've got our orthographic projection in 3 views. Now with basic views, there is no limit on the number of views that you can use. 3 will usually be enough, the front, top, and right side being your most common. Bottom, left, and other side views may be included as well, but they're usually not necessary. But again, if you want to have 500 different views for a print, you can. It would be a lot of clutter and it would be very confusing for somebody to read, but you could still have as many views as you want. Front view usually will give the best indication of the shape or detail of a part, and then the profile selected for front view describes most detail. So those are the two keys if you were to take an object like this and decide which one of these will be my front view. Now for this one, I went with this to be our front view because I feel like it gives me the best idea of the shape of the object. If you use this as the front view, that doesn't work out because all you'll see is a square with 2 holes in it. You choose that as the front view, that doesn't work out either because again, all you would see would just be a square with a few hidden lines there and be really confusing. But choosing this to be the front view allows us to let us know that the part is L-shaped. The front view will give the best indication of the shape and detail, while the profile selected for front view describes the most detail. Views have specific position with the relation to each other, horizontal or vertical alignments. So on this side, you can see that each view is aligned with each other. The front view is going to have the top, back, and bottom view aligned vertically with each other, while the right side and the left side are going to align horizontally with each other. And they're going to keep these lines in line with each other to not confuse you and get it all shaken around. Because if you were to take that front view and put the top view to the right side, it'd get confusing really quick because you think, oh, I'm looking at the right side view, but on a label there it says, no, this is the top view. Well, that's confusing and that's not good. You don't want that. For over this chapter, we know that lines will determine the shape and dimension of an object. Drawings describe object in sufficient detail for fabrication. Views have specific arrangement. There's no limit on the number of views, and the profile selected for the front view describes the most detail. Now, this one is a very basic print with just this L-shaped object, and I decided to take something a little bit more complicated to kind of show you. So this here is a Lego brick. I scaled it up 4 times, very simply. Now, if you were just to look at a basic Lego brick, it's not too complicated. You think there's just a square there, and this is the basic 2x4 stud. So 2 this way, 4 this way. So 2 studs, 4 studs, basic 2x4. Now, from the front view, you'd think there's not much there. Well, once you add in the element of hidden lines, you can actually start to see, because if you view it from the bottom, you'll see there's 3 cylinders on the inside of there, and further inside of the piece, the studs that come out of the top have little dimples inside of them as well. And then there's these 2 support structures right there. Now, I've drawn them all out as hidden lines on the inside to see the orientation. So this part right here represents that cylinder in the inside. This part here represents that other cylinder on the inside as well. Now, these other hidden lines that go around the side of the square, those show you the actual thickness of the material itself on the Lego brick, because it's not just this plane and then nothing else at all. There's actual thickness to these walls. So what it's showing you is the inside edge of it. That's what those hidden lines represent. If I took a cutting plane line and drew it across here and cut it out, which I probably will do later, it'd be a good show of a cutting plane and how you'd actually show the internal structure of it, and these hidden lines would switch to object lines so you could actually see what's going on inside of it. For our side view, we just turn it to our right side, and then you can see there's the 1 cylinder on the inside that we can see represented by hidden lines, and the internal walls themselves, and then the studs sticking out. And then from our top view, we can see that those internal hidden lines right there are actually those cylinders on the inside, and that these parts sticking up are round as well. And then internally, they have those other object lines inside of them, or those other hidden lines inside of them. And then we've got 2 hidden lines here representing the support structure on the inside of this brick. And this print is just kind of to show how much more in-depth the use of object lines and hidden lines can get with even just a super simple object that we see every day.